So for example 3, we want to look at two different functions. We want to look at g of x equals parentheses x minus 5 quantity cubed plus 4. And then for part B, we want to look at h of x equals parentheses x plus 2 squared minus 2. The first thing I want you guys to notice is these do not have the same parent function. They have different parent functions. So for part A, the parent function is y equals what? X to the third. Yeah, it's just you drop the parentheses and the numbers and you just keep the variable and the power or the symbols. So it'll just be the basic x cubed. But for part B, the parent function would be y equals what?
X squared.
X squared. So let's just take off part B and focus our attention only on part A for now. Uh-oh, I was just kidding. Hold on. Hey, look, this is not my day. Let's take that one off. I was never a very good colorer in kindergarten. Apparently I still am not. There we go. Let's take part B off. How many translations does part A have to it? 2. Does it have a vertical?
Yes.
And does it have a horizontal?
Yes.
Yes, so it has both. So we have to talk about those. And vertical and horizontal are nice because it really doesn't matter what order you do them in. But before we do, let's go ahead and find the parent. The parent we've already talked about is y equals x to the third. So remove the minus 5, remove the plus 4, so take the translations off. What's left is called the parent function, the unshifted parent function. Then we want to identify the different translations. The first, let's talk about vertical. The vertical shift for this one is positive or negative 4? Positive 4. So the one on the end here is your vertical. It's positive 4. So we'll say that it's up 4 units. And then the horizontal translation, or sometimes abbreviated the horizontal shift, is positive 5 or negative 5? Positive 5, which moves it to the right. So to the right 5. Those are the two things I need to do. And the nice thing is technically with vertical versus horizontal, it doesn't matter which one you do first. So you can't get in trouble. So let's go ahead and let's graph the parent. The parent is y equals x cubed. And if you're not sure what the parent graph looks like, you can, in your mind or somewhere off to the side, you can just make a quick table. So if I'm going to graph just the parent, if x is 0, 0 cubed is 0. So I'll put a dot at 0, 0. If I put in 1, 1 cubed is 1. So the point 1, 1 is on there. And if I put in 2, 2 cubed is 8. 2 and 1, 2, 3, 4, 5, 6, 7, 8. And then if I put in negative 1 to the parent, remember we're just finding points for the parent. Negative 1 cubed is negative 1 and negative 2 cubed is negative 8. So that will give me enough points to understand what the parent looks like. Now, we're pretty familiar with these. We know that that's the basic cubic because we just spent a whole lesson talking about those at the beginning of section 3.3, right?
Yep.
Okay, so we kind of know what the basic graphs look like. All I have to do now is take every one of those points, Bryce, and shift them up 4 units and to the right 5 units. That's all. So I'm going to start down here, and I'm going to move this point up 4. 1, 2, 3, 4, and to the right 5. 1, 2, 3, 4, 5. This one goes up 4. 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. We're here now to kind of the center. Up 4 and over 5. Did that work, or did I miss one? Got it? All right, now I'm right here. I need to relocate this point. Up 1, 2, 3, 4, over 1, 2, 3, 4, 5. And this one, I'm kind of off my graph, but we could still see that it would go up about 1, 2, 3, 4, and to the right 5. So it's just going to maintain its shape. It's just been relocated up and over. How's that, you guys? Make sense? Yes? And then you just redraw the same shape. You guys are starting to look bored. Are you bored? Well, I must not be talking fast enough. Oh. All right. Let's clear this off now and let's go back and look at part B. So for part B, we're asked to graph h of x equals parentheses x plus 2 quantity squared minus 2. So I just feel like there's just a few too many 2's in this problem.
Yep.
But putting that aside, what's the parent function?
X squared. Y equals x squared.
So the parent is y equals x squared, which is just your basic parabola, right? All right, let's go graph that. We know that that vertex occurs at 0, 0, so we'll put a dot there. Now substitute 1 in. If you put 1 in, what do you get?
1.
So that would be the point 1, 1. What about 2?
4.
2, 4. And then 3 is up to 9, so I think that's enough, right? Negative 1, however, becomes positive 1, and negative 2 becomes positive 4. So there's the basic graph for any parabola. That's the parent. Okay? Now if I take that parent and I shift it, what's my horizontal shift? Left 2. Very good. Left 2. And my vertical shift is down 2. So we need to take all of those points, so all 5 of those points, and move them 2 units to the left and down 2 units. So we're going to go ahead together and do our vertical and horizontal shifting all at once. So left and down, left and down, left and down. Oh my. This gets old really fast. Left and down, left and down. So there is the final graph. So that went a lot faster than the cubic because we're just more comfortable with y equals x squared than we are with y equals x cubed, right? So depending on your comfort level and your familiarity level with your parent function, it may not take you very long to do these. It just depends on how quickly you can get them graphed.